The ADCPs on this ship, ADCP Acoustic Doppler Current Profiler. Acoustic because it pings, just like shouting into a canyon. So you say, hello, and then the sound, in the case of these instruments, echoes off of plankton poop, gradients in the density, things like that. It reflects and it comes back. And since it was pinged out at a given frequency, if any of that stuff is moving, it'll come back at a different frequency. That's the Doppler part. So like the train, you know, it goes past you and the sound frequency drops. So we ping out at a given frequency along a beam, and if the sound is moving, if the water is moving towards the instrument, then the pitch comes back higher, and if it's moving away, then it comes back lower. And the shipboard ADCP is on the ship, so it's got two beams facing forward, which is that direction. I mean, where we are now, I'm looking backwards, but it's got two beams facing forward, so those two beams come back with positive or higher pitched values, and these two beams come back with lower pitched values. But it has four beams, and so each opposite pair of beams describes a plane, and that plane means that you've got a along the beam velocity here and an along the beam velocity there, and you can decompose that into a horizontal and a vertical. So there's a horizontal and a vertical for each of these pairs, which means you've got two horizontals, and those are in ship coordinates because this thing is bolted to the bottom of the ship. So you have motion past the package that's measured in ship coordinates, which is, from this perspective, it's like looking through a hole in the floorboards of your car. All you know is what's going past you. You are just plain, you're the ADCP, and you're in the front seat of the car looking through the floorboards, and all you see is the water going backwards. So what you need to do to find out what was going on underneath you is to remove the motion of the vehicle that you're in. So if you think about this car analogy again, if you're driving, let's say slowly so that you can measure it, if you're driving slowly over the road and the road doesn't move, then it just goes backwards. If you're driving slowly over the road and there's a sheet of water going across the road, then you'll see, actually, you won't see things going straight backwards, but they'll have a little bit of an angle to them. And so that's what we try to take out. There's the measurement of the ocean relative to the package, and then you orient that into ship coordinates, and the ship is facing north, so you take the heading out, and what you're left with after a lot of linear algebra and some editing is the ocean velocity.